All right, so in week 3, we are working with these integer exponents in scientific notation. So this is all about understanding and knowing those exponential rules or exponent rules, right? And so for this first one, we're understanding negative exponents, which basically say if I have a term raised to a negative exponent, I just reciprocate that term and make the exponent positive, right? So, if I have instead of a to the negative 9, I got 4 to the negative 4. So I'm going to just reciprocate that and make the exponent positive, right? So my solution for this is going to be 1 over, what, 64 and 4? What's 4 to the fourth power? So 4 to the fourth power, get out of there. 4 to the fourth, I think is, yeah, 256. So 1 over 256 will be our solution. All right. So now the biggest mistake I see sometimes is people do not understand that 6a to the negative 7, this is really two terms. This is 6 to the first times a to the negative 7, right? So the only thing that's going to reciprocate is the a to the negative 7. Okay. So if we was writing this out long way, we would say 1/6 divided by 1 over a to the positive 7, which we know that if we're dividing two fractions, it becomes multiplication and we reciprocate the second fraction, right? And so that becomes a to the 7 over 6. We're doing the exact same thing when we say just reciprocate the negative, right? So the 1/6 won't be touched. A to the 7th reciprocates to the numerator. And then, of course, anytime we have a a variable, we assume that the 1 is always there, so you don't need to put it there. So our final answer would be a to the 7th over 6. All right, next, question 3. Now we can start doing some simplification, right? And so the coefficients, we just need to multiply those out because this is multiplication. All right, so 12 times 5 is going to give us 60. And now when we have the same base and it's multiplication, we just add the exponents. So that's going to give us 60 to the x to the negative 6 power. And now, again, only the x has the negative exponent, not the 6, 60. Remember, 60 is to the imaginary power 1. So our final solution is going to be 60 over x to the 6. All right, question 4. We have a couple of things going on, right? So we have we got some multiplication going on where we can simplify this a little bit, and then everything is raised to the power rule. So we can look at this a couple of different ways. We can first multiply the 2 and the 3, which gives us 6, and then have a to the third, b to the fourth, and all of this is raised to the second power, right? Or you can just simply put the 2 into everything, right? So if you put the 2 into everything, so first let's do it this way. So 6 to the first raised to the second is just 6 to the 1 times 2, which is 6 to the second. A to the third times the second power, because we're raising the power to a power, is just going to be a to the 6. And b to the fourth to the power of 2 is going to be b to the 4 times 2, which is 8. Then I just simplify 6 to the second power is going to be 36, a to the 6, b to the 8th, right? Had you not did that, and you just said 2 to the second, 2 to the second times a to the 6 times 3 to the second times b to the 8th, that will become 4 times a to the 6 times 9 times b to the 8th. 4 times 9 is 36. A to the 6, b to the 8th, right? We end up with the same exact solution. All right, number 5. Okay. Like, again, if you don't understand the rules, right, this can look very intimidating. And especially if you want to write this out the long drawn out way, it takes a little bit of time. But since I have a negative exponent in my numerator and a negative exponent in my denominator, I just reciprocate these. And that's only the x and the y. The 3 doesn't get touched. So basically, this fraction is still to the 1/3. The only thing that's going to happen is I'm going to move the y to the negative 6 to the numerator and make it positive. I've done the negative exponent rule. And then I'm going to move the numerator to the denominator and make it positive. I've done my negative exponent rule. And of course, when I have a variable with a coefficient of 1. I don't need the 1. So my final solution is going to be y to the 6 over 3x to the 6. Okay, question 6. 5 to the 0 power. Anything to the 0 power is just 1. I showed that in the video earlier. Okay, because if we were to take 5 divided by 5 and say it equals 1, that's because 5 is raised to the imaginary power of 1. And our quotient rule says if my bases are the same, subtract my exponents. Okay, 1 minus 1 is 0. Therefore, anytime you have something raised to the 0 power, it is going to give you 1. All right, so I'm going to pause right there, let you get caught up on your notes, making sure you're understanding how these processes are working, and come back here and answer the questions on page 2. Talk to you shortly.